Okay, so today we're going to look at section 9.5, which is nets. So a net is when you break down a 3D shape into a flat shape. So for example, this cube, so the green bit is the base, and if you fold it down the sides and then the top is attached to one of the sides, this is your net. So you need to be able to imagine going from this to this, or from this to this, because sometimes you might be asked, is this a net of a cube? Alright, so you have to imagine you fold up the sides and then this bit goes across the top. Okay, so if it's a rectangular shape, then it's worth noting that the base and the top, so the bottom and the top, are going to be the same. The two sides are going to be the same, and the front and the back are going to be the same. Okay, this would be the net of an open box, because you'd have the two sides and the back and the front, and the base you don't have the top. Alright, now there are 11 different nets of cubes. These are two of them. Your T shape, and here are some more. So this is one, this isn't, this is one, this T is one, this is one. Alright, and they're not. So when you were given a picture, you need to imagine, if I fold this up and that goes around there and that goes around there and that goes around there and that goes around there, does it make the net? Does it make a cube, or are any of the sides overlapping? If they overlap, then it's not a net. For example, this one, I'd fold this up, but then I have two on the top, so it can't be a net. So that's why some of them are and some of them aren't. Okay, so the thing we're asked to do in this is, by drawing the net of this cuboid, find the total surface area. Alright, so this is 10, this is 10, this is 5, this is 5, this is 5, this is 6, this is 6. Okay, so start with the base. So the base is 10 by 6. Okay, and then out of the base is the front, which is a 5. That's the front, and the back is going to be the same. Okay, and then the sides, if I go out the side, this is 5. So if you look at pieces like this, have to be the same, because when they fold up, they're going to fold up together. And then so I have the back, the front, the two sides, the base, so the only thing that's left is the top, and the top is going to be the same as the base. So this is the top, and it's 10 by 6. And that's your net. So it said, by drawing the net, find the surface area. So surface area means all the pieces you can touch around the outside. So when you have the flat shape, it's just the area of each bit. So this bit is 10 by 6. This bit is 10 by 5. This bit is 10 by 6, and this bit is 10 by 5, and this bit is 5 by 6, and this bit is 5 by 6. So you can just write all of those out here. 10 by 6, 10 by 5, 10 by 6, 10 by, that should have been 5, 5 by 6, and 5 by 6. So 60, 50, 60, 50, 30, and 30. So 280. So you add them all together. So the surface area, is equal to 280. Alright, so that's if it asks you to flatten it out into a net and to get the surface area. So we could have got the surface area doing it the way we did it previously, which is get the area of the front multiplied by 2, get the area of the top multiplied by 2, and get the area of the side multiplied by 2. Okay, so let's look again just at question 3. The diagram shows a net of a cube with a different letter on each face. When the cube is assembled, which letter is opposite the letter A? So let's say B is my base. So when these fold up, C is opposite A. Okay? And then when these fold up, E is opposite F. And then when C folds up, it's a side, and D folds up and across the top. So D is across from B. Okay? So your answer, what's across from A? It's C. What's across from E? It's F. And what's across from D? It's B. Okay. Question 2. The net shown is folded to make a rectangular box. The pink rectangle will be the base of the box. Write down the height of the box. Okay. So let me draw roughly what they have here. So this is the base, okay? So my base is 12 by 8. And then the height is 7. Okay? Sorry. So this is my base. If that's 12, that's 12, that's 12, that's 12, that's 12. If that's 8, that's 8, that's 8, that's 8. So it doesn't really matter how you draw it, just draw it. It doesn't have to be drawn to scale, but you're just looking, it's 12 by 8 for the base. So then there's only 3 measurements. The other measurement is height, which is 7. So part 1 says the height. So the height is 7. Is the box open or closed? Closed, because we have 1, 2, 3, 4, 5, 6 faces. Find the volume of the box. So volume is 7 by 12 by 8. Which is 672 centimeters cubed volume. And work out the surface area. Okay, so the surface area we can do 2 ways. We can do it from our net. Okay, so this, if this is 7, this is 7. If that's 8, that's 8. And if that's 7, that's 7. So this bit is 12 by 7. This bit is 7 by 8, 7 by 8, 12 by 8, 12 by 7, and 12 by 8. Okay, so you can, your surface area is equal to 12 by 7, 12 by 8, 12 by 7, 12 by 8, 7 by 8, 7 by 8. So you can calculate them. And then add them up. Okay. 56, 56, 96, 84, 96, 84. Okay. So that's it. Sorry, there's 427 centimeters squared. So I want you to try exercise 9.5 on page 213, questions 1, 4, 5, 7, 8, and 9. Okay.